3D localization becomes difficult when you have reflective objects or partially hidden objects or objects that have very complex shapes. HALCON shows you, or this demo shows you, how HALCON makes these situations manageable. Hi, my name is Coco and I'm working as an application engineer at MVTec. Currently, we are standing in front of the Deep 3D matching demo. This demo shows how our Deep 3D matching method can robustly locate even difficult objects like these transparent bottles robustly using only 2D sensor information. So there are 4 points that make this setup technically special. The first one is that it's a hybrid approach. So Deep 3D matching combines deep learning and rule-based algorithms for more precision and control. The second point is that we do not use a 3D sensor, but only 2D cameras, as you can see here. These 2D cameras are sufficient to detect the 3D pose, so there are no point clouds, just images from different perspectives. The third point is that we do not require any labeling to train the Deep 3D matching model. We just need a CAD model, and then we have a physics engine that renders realistic data to train the model. And because this data already comes with ground truth, we do not have any manual annotation. And the last point is that it's a very robust method. So even if your objects are transparent, reflective, or partially occluded, Deep 3D matching can robustly locate the objects. Let's walk through the setup step by step. So we have a calibrated setup here. In this case, we use 4 different cameras. 2D cameras are sufficient in this case. Then we acquire 4 images from different perspectives of the bottles. We then give the images to a detection network, which determines the bounding boxes around the bottle in each image. These boxes are then given to a 3D pose estimation network, which determines the 3D pose for every candidate. After that, we use a classical approach to group the poses, and at the end, we get 1 3D pose per bottle, which you can then also see on the screen. The processing time is around 200 milliseconds. In this case, we use an NVIDIA RTX GeForce 4080 for the inference. In real production, this Deep 3D matching approach is, for example, used for bin picking applications, where you have a container with unsorted objects, and they can, for example, be partially occluded or transparent like these bottles, and Deep 3D matching can robustly locate the precision of these objects. The second scenario is robot guidance. So if you need a precise precision for pick-and-place applications, for assembly, logistics, and things like that, then Deep 3D matching is the method to go for. So Deep 3D matching brings robust, label-free, and CAD-based 3D localization to real industrial environments.